In this section, we're going to talk about the sum and difference identities for cosine. Before we get into the identity, let's take this expression or equation right here. If I have the cosine of two angles, A minus B, written this way, the cosine of A minus B, is that equal to just the cosine of A minus the cosine of B? In other words, can I use the distributive property like we've done in many other cases in algebra? Does the distributive property apply for my trig identities? So that's what we're questioning here. Let's see if we can answer this by letting the angle A be pi over 2 and the angle B equal to 0. So if I had the cosine of pi over 2 minus 0, I'm asking, is that the cosine of pi over 2 minus the cosine of 0? So just working on the left-hand side over here, this simplifies to be the cosine of pi over 2. And I'm going to just go down straight here. If I have the cosine of pi over 2, well, the cosine of pi over 2, if you remember, is just 0. And I'm going to see if the right-hand side is going to be equal to 0. So again, the cosine of pi over 2 is 0, but the cosine of 0 is 1. And so we can see that obviously 0 does not equal negative 1, and so therefore we cannot just apply the distributive property if I have two angles that I'm taking the cosine of. So what do? Well, there's an identity that we're going to use, and these are called the sum and difference identities for cosine. You can see here that I have two different cases. The first case is written out for you here, where I have the cosine of A plus B. That equals the cosine of the first times the cosine of the second minus the sine of the first times the sine of the second. And I'm talking about first and second of the angles. And you can see that for the second one, where we have the difference of my angles, the sign, the addition sign is what breaks out in this identity. Okay, so we're going to go ahead and see how we apply this to a couple of separate examples here. So in each of these examples, I want to find the exact value of the expression using either the sum or difference identity for cosine. So I have here the cosine of negative 75. When I look at this, and I start to ask myself, is 75, or negative 75 even, is that a common angle that we know of off of our unit circle that we've been memorizing? It's not. So how do I find then the exact value of cosine? Well, what we want to do is we want to take two known angles that are then going to add to give me negative 75 and use them to find the answer. So when I look at this cosine of negative 45, I want to say what two angles that I know of that on the unit circle add together to give me negative 45. There's a couple of different combinations. One of them that you may have thought of is if I take the cosine of negative 45 plus the cosine of plus the cosine of negative 30. Well, negative 45 plus negative 30 is negative 75. And I know what the cosine of negative 45 is, and I know what the cosine of negative 30 is. So we're going to use these two values here to find the exact answer. This breaks up into the cosine of the first, so we have the cosine of negative 45 times the cosine of the second. We're doing the sum identity for cosine, so this sign down here is a negative or a minus sign, minus the sine of the first, which is again negative 45, times the sine of the second. Oops, too many parentheses. Times the sine of the second, which is negative 30. So the cosine of negative 45, okay, so the cosine of negative 45 is down here, and that would be square root of 2 over 2. Cosine is positive in the fourth quadrant, so it's the square root of 2 over 2. And the cosine of negative 30 which is about right there, is going to be the square root of 3 over 2. So then minus the sine of negative 45, which is a negative square root of 2 over 2, because sine is negative in the fourth quadrant. And the sine of negative 30 is negative 1/2. Now it's just simplifying these fractions here. When I multiply the two fractions here at the beginning, I get a square root of 6. So 2 times 3 is the square root of 6, all over 2 times 2, which is 4. And here I have minus the square root of 2 all over 4. And that's the solution. You may see it written as a combined denominator, or in other words, the square root of 6 minus the square root of 2 all over 4. Both of these answers are the same. Now, because the square root of 6 and the square root of 2 both have different bases or different values underneath the radical sign, different bases, I can't combine these two. Just remember that. So these are not like terms. So this is the solution. Most of the time when we do the sum and difference of these identities, we get strange looking solutions that look like this. Now, one other thing I want to point out to you. What if I came up with another way to get the cosine of negative 75? So if I have the cosine of negative 75, I could also have used, say, 360 minus 75, which would give me 285, right? So in other words, what would the positive angle be equivalent to negative 75? So if we're down here at negative 75, what is the positive angle? And that is actually 285. So maybe I want to ask myself, okay, what numbers do I know of that add together to give me 285? In the positive direction. Those could be the cosine of, say, 225 plus 60. I know how to find the cosine of 225. I know how to find 60. Those two values add up to be 285, which is the same angle as negative 75. And so if I were to use the sum identity for cosine with these two angles, I would end up with the same solution that I had using negative 45 and negative 30. So there's multiple ways to think about using the sum or difference identity for cosine, but the key is just finding two angles that either add or subtract to give me my original angle I'm looking for.